Day 2, section 7.4 still, but I split it up into 2 days so you could just concentrate on the first special right triangle, the 45, 45, 90, which I'll admit it's a little bit easier, but if you grasp the concept, then it can work with a 30, 60, 90. 30, 60, 90 is also a special kind of right triangle, not because it has congruent legs, but if you draw this triangle, go ahead and draw it right now unless you have this on a handout. And again, I'll remind you that it's the side across from the 30-degree angle. You're looking at, I'm trying to get rid of my screen. You're looking at the 30-degree angle. It's looking and staring across the room at its side, which is the X. The 60-degree angle is staring across the room at its side, which is the square root of 3. The 90-degree angle is staring across the room at its side, which is 2. As you know from the triangle inequality theorem, if I type in the square root of 3, it's only 1.73. So you're not quite doubling this side. You're taking this side times 1.73, and then you're taking this side times 2. So definitely the hypotenuse is still longer, because whatever this short side is, it gets doubled. The x square root of 3 is a medium size, and we know that, if you remember it from chapter whatever, 5 or 6, that across from the smallest angle should be the shortest side. Across from the medium angle should be the medium side, and across from the largest angle is the largest side, so it still works. Now, what makes this so special? It's not much more special than a 45, 45, 90, or what if it was a 20, 50, 90, but the reason why a 30, 60, 90 is special is because it's actually half of an equilateral triangle. If you want to draw this on there, use a dotted line, but it is half of its equilateral triangle. An equilateral triangle is a perfect 60, 60, 60. It definitely makes sense here. Why is that side across from the 30 exactly half as big as the side across from the 90? And it's because the side across from the 30 is only half of that equilateral triangle, whereas the hypotenuse is double that distance. By far the biggest confusion or misrepresentation that students have is they think across from the 30 is x, and since 60 is twice as big as 30, they put the 2x over here. Don't let that happen to you. Picture a perfect equilateral triangle every time if it helps you know that the smallest side is x, the biggest side is 2x. It's this third side, this middle side. It's like the middle child. Nobody really likes the middle child. Like, no offense to the middle childs. Me. Okay? Barely, kind of, sort of, almost a middle child. My younger brother is 12 minutes younger than me, but that still puts me in the middle, right? I'm a little older than him, and I'm a couple years younger than my sister. But here's the middle child. It's a little bit different. It's the medium size. And if you can picture it as a 30, 60, 90 triangle, half of an equilateral triangle. So let's go ahead and make the tic-tac-toe that we did on the previous. And this time you're going to get 30, 60, 90 degrees. And your formula will be across from the 30 is x, across from the 60 is x squared root of 3, and across from the 90 is 2x. If you have a number, then, and we know an answer, the easiest by far is when they tell us the short side. If you knew, like, yep, I got it, the short side is 4. Okay, the short side is 4. That's the easiest one to do because then it says take that 4 and multiply it times square root of 3, or go back and take that 4 and exactly double it. So if they give you the short side, it's pretty similar to the 45, 45, 90. The difference is, what if they give you the medium side? What if they give you the large side? You're going to have to do some magic multiplication and division in the meantime. All right, go ahead and draw this triangle. They only gave us 2 of the angles, but we automatically know, either from the triangle sum theorem, that this is 30 degrees because it adds up to 180. Or the corollary to the triangle sum theorem is that the acute angles equal 90. That's faster, easier. So across from the 30 is 8. I'm going to tic-tac-toe this one. You too. Pause it and see if you can fill this out without me. Ready, go. All right. Yours should have a 30, 60, 90. It'll always have the x, x squared, 3, and 2x. And then it's a matter of, because they gave you the short side of 8, you know that the medium side is 8 square root of 3, and you know that the largest side is 16. So you would take this information from your tic-tac-toe, transfer it over here, make sure that 8 square root of 3 ends up across from your 60-degree angle, and that your 16 is the largest side, or a side opposite of the 90-degree angle. And always visualizing in your head that this used to be an equilateral triangle. That's why this is half as big as that is. And trust me, you're going to need to know this, because of course, we're going to turn these into area, and we're going to try to find areas of triangles. But then we're going to go two-dimensional and make it a little bit bigger, where we're going to need to find the area of a hexagon, or a pentagon, or a septagon, or an octagon, or something. Well, guess what? If you're going to do one of those, you're going to find the area of this triangle, and of this triangle, and this triangle, and this triangle, and this triangle. And then we're going to take that hexagon, or pentagon, or octagon, or whatever it is. I need more space. I'm excited about this. We're going to take our little triangle, but then turn it into, was it an equilateral triangle? Possibly. But then we're going to go two-dimensional and turn it into a bunch of triangles. But then we're going to go three-dimensional and turn it into a prism. And we're going to say, hey, you, find the area of that prism. And if you're still, let me get this all the way down here. If you're still working on finding the height of this little triangle by using your handy-dandy Pythagorean theorem, and by the time you get done finding the height of that little triangle, somebody else already has the entire area of the full three-dimensional prism figured out. So trust me, get good at special right triangles. It'll help you a lot. Let's try this one. Pause it and draw it if you need to. Across from the 90-degree angle is 20. Across from the 60-degree angle we don't know, and across from the 30-degree angle we don't know. But we do know that we have the largest side. And the largest side right now is 20. You can take the time to fill out the rest of the tic-tac-toe if you need to. What the heck happened to my tic-tac-toe? There we go. You can fill out the top and the middle if you need to. If we're going from 20, which was the double X side, we can't find this side. If you're looking for this side next, that doesn't really work, because 2x and x squared 3 are not related. They're not connected at all. But they are, but we don't want to get that complicated. But if we go all the way back to the x side, let's make it easy on ourselves. If we know that the hypotenuse is 20, then the short side has got to be 10. It's exactly half as big. We're working backwards, so we're now dividing by this number. And if we know that the side across from the 30 is 10, that's the small side, now we can work our way forward. If we know x is 10, you just put 10 in for the x and make it the square root of 3. Don't try to find a direct relation between the medium side and this large side. We don't want to go medium to large, and we don't want to go large to medium. Let's always work around the small. Oh yeah, focus on the small. There we go. There's the baby of the family. Small one is going to get all the attention, and we're going to say, well, what is he going to be? What does he want to be? What is he? Once we know that this is 10, you can just work with multiplication to find the other two. So keep that in mind as we work through this. Let's try this one. Take the time to draw it. Set up your tic-tac-toe. Put in your 60 degrees if you want to, if it helps. Then you know that your 60 degrees is staring directly across the room at that beautiful 15 square root of 3 over there, trying to get the nerve to walk all the way across the triangle to go ask a question. We know our x squared root of 3 side. We know the 60-degree side. We know it's 15 square root of 3. We can't find its big side. We're not going there. We're not going to go find the big side. We're going to go find the smallest side. We're going to look for the 30-degree angle because we know that the 30-degree angle is exactly square root of 3 times smaller. So if we take 15 square root of 3 and we divide it by square root of 3, we know that the square root of 3 disappears and our x value is 15. And if our x value is 15, then that helps us get to our 90-degree side, which is twice as big as the x value, which is 30. 15 times 2 is 30. 15 times square root of 3 is 15 square root of 3. Now just make sure you transfer this from here directly over here, that you know the short side is 15, the long side, the diagonal side, the hypotenuse is 30. Okay, so yeah, it's more difficult than 45, 45, 90s because you have 3 different sizes to work with. And so far, I haven't even given you the tougher one. You're going to say, there's always something, Mrs. Bester. Why is there always something that's harder? Because it's math. We got to take the next step. They're not always going to give you the easy problems in real life. If you're trying to construct a skateboard ramp, and the skateboard ramp is a 30, 60, 90 triangle. Okay. This time, you know that the 30 side is 4 square root of 3. And you're like, they put it in the wrong spot. The 4 square root of 3 is supposed to be down here. There is no supposed to be. It's just what's easier and what can you do in your head and what do you actually have to calculate. So we know that in the 30-degree side, this is supposed to be x, and your answer is 4 square root of 3. So I know that this entire value, 4 square root of 3, all is represented by x. Which means the side across from the 60-degree angle, I have to multiply my x value times the square root of 3. Good thing we did radical review and practice these, and if you're not good at radicals, let's go back and do that worksheet and get help at that before we try to do special right triangles. If you take 4 square root of 3 and you multiply it by square root of 3, 2 ways you can do this, the long way or the short way. Long way, square root of 3 times the square root of 3 is 9. Square root of 9 is 3. 4 times 3 is 12. Short way, square root of 3 times the square root of 3 is 3. And I know that 4 times 3 is 12. Or you can do that part in your head. So you now know that the side across from the 60-degree angle is 12. Seems weird, and you're like, is that right? Did I do that right? Well, then you check it. You take 4 square root 3, and you multiply it. Say, well, I was supposed to multiply it by square root of 3, which is about 1.73. And you multiply it times that. Oh, okay, I did do it right. But then this 12 is not related at all to the 90-degree angle, and we're going to do the 90-degree angle by going back to the 30-degree angle. I know that it has to be twice as big as this x. And all of my x is 4 square root of 3. And if I take 4 square root of 3 and I multiply it by 2, only the rational numbers get multiplied by 2. This whole number, it's not 8 square root of 6, it's 8 square roots of 3. If Jimmy has 4 square roots of 3, and somebody has twice as much as Jimmy does, Sally then has 8 square roots of 3. And then, of course, that's the longest side, so you put it over here, and you're like, what? 8 square root of 3? That's not bigger than 12, is it? You bet your slippers it is. 13.85, which is bigger than 12. So you make sure you put them in the right spot. Short side, medium side, large side. We've got 2 left. Hang in there. 6 square root of 3. That's across from the 90 side. We don't know the short side at 30 degrees. We don't know the medium side across from the 60 degrees. Fill it out. We know the side across from the 90-degree angle. We know it's supposed to be twice as big as x. We know that it actually is 6 square root of 3. If we want to go backwards on the tic-tac-toe, we definitely need to divide. But we cannot divide to the 60 side because we have no relationship, or a very awkward relationship, between x squared root of 3 and 2x. So we're going to go all the way back to the 30-degree side. Let's find the short side of the triangle first. So if you take 6 square root of 3 and you divide it to get all the way back to the small side, you are going to divide it by 2. 6 square root of 3 divided by 2 is 3 square roots of 3. Again, Jimmy has 3 square roots of 3 in his pocket. Sally has twice as many, so she now has 6 square roots of 3. Now I'm going to work my way back forward, knowing that 3 square roots of 3 has to get bigger yet. How much bigger does it have to get? It has to get multiplied by square root of 3. We're going to shortcut this again. The square root of 3 times the square root of 3 is 3. And 3 times 3 is 9. 3 times 3 is 9. Don't put 3 times 3 is 6. If you're not surprised, I've seen that before. 3 times 3 is 9. So I have my 3 sides of the triangle. I just have to make sure that I label them properly. Across from the 30-degree angle is this small little 3 square root of 3. Across from my 60-degree angle is this 9. And across from my 90-degree angle is 6 square roots of 3. 6 times 1.7 can't be that big, can it? 6 times square root of 3. Yeah, it can. 10.39. So it's larger. The hypotenuse is the largest side. Last one. Working with an equilateral triangle. Just like in the previous day's notes we worked with a square. Now we have an equilateral triangle. We know it's equilateral because it has 3 congruent arc marks. If we have 3 congruent arc marks and a perfectly straight up and down, right smack down the middle, all of these arc marks are 60 degrees, but throwing the median right down the middle, you make 2 30-degree angles. Where is this 15 mark? It's across from the 60. We really need the tic-tac-toe for this one. Across from the 60 is 15. Oops, wrong spot. I really wish that had a square root of 3 in it to make my life easier and make it easier to teach and make your life easier, but there's not a square root of 3 in it. We have to work our way down to the small side. How big is this small side? It's square root of 3 times less than the medium side, which means we're going to take 15 and divide it by square root of 3. 15 divided by square root of 3. Multiply the denominator times itself. Square root of 3 times square root of 3 is 3. Whatever you do to the denominator, you do to the numerator. 15 square root of 3. But 15 square root of 3 divided by 3 is 15 thirds. 15 thirds reduces down to 5. Don't touch the radical. He's in jail. He stays. Square root of 3. What if we had to do 15 of those in a row? Would it take you this much time? Like we had to do the square root of 2. We realized our shortcut was divide by square root of 2, so you're cutting it in half every time. Well, this time we're dividing by square root of 3, so we're cutting it in thirds every time. 5 square root of 3, I need to double that to get over here to my 90 degrees. And 5 square roots of 3 times 2 is 10 square roots of 3. So we have our 3 sides. We just have to know where to put them. 5 square root of 3 goes on half of the triangle. You can put it again over here if you want to fill out the whole thing. The hypotenuses, is that a thing? Hypotenuse are 10 square root of 3, and the side across from the 60, which happens to be the height of the triangle, is 15. All right, just for kicks, let's do 3 of these. What if you have 9, and you have to divide it by square root of 3? What if you have 12, and you have to divide it by square root of 3? What if you have 14 and you have to divide it by square root of 3? You could divide by square root of 3, rationalize it, get 9 square root of 3, divide it by 3, reduce it, and get 3 square root of 3 every time. Or you could say, I recognize this. When I divide by square root of 3 over here and put it over here, that's exactly a third of that number. So this one becomes 4 square root of 3. Let's throw another one in there. What if I had x squared root of 3 equals 21? If I want to know what x equals, I would know that it's 7 square root of 3. Doing all this math in my head kind of shortcut. If I want to take, x squared root of 3 equals 14, and I had to divide this one, I know that it's not a whole number, but I know it's going to be a third of whatever 14 is, and multiply it by square root of 3. Just a quick practice, in case you needed it. That's it. I'm done. Special right triangles. Bye.